Implementation of E542 under Professor Youngchu. Today, me and my partner Akshay are going to walk you through what we did with xDot. So let's look into the task which was given to us into this lab. So in this lab, we were told to implement a custom firmware for xDot for prototyping an end-to-end IoT solution. So for this, we basically made use of two kinds of sensor, the thermistor and the ultrasonic sensor. So the thermistor circuit was basically used in the sense to measure the temperature variation, and once we got the variation of the temperature, we send it to xDot, and via xDot, and all this communication was done over the UART port. So UART ports are generally used for your TX and the RX, which is your transmitter and the receiver ports. Similarly, we also made use of the ultrasonic sonar sensor to detect the temperature, to detect the proximity to the next obstruction. And once the obstruction was detected, the same data was sent continuously back to the xDot and was displayed on the terminal. So for performing the whole task, we made use of the embed environment. So that was the platform over which we were running our xDot code over. Initially, we tried with a LED, and then we went on to write the code for thermistor and then for the ultrasonic sensor. Now Akshay is going to walk you through how we went about doing the thermistor sensor.
So the first sensor we use here is the thermistor sensor, and we connect it directly to the xDot via the UART ports, which is the TX and RX ports. We sense the data using this circuit as shown here in this PPT. So basically our idea is to vary the resistance with the temperature, as we all know that the resistivity varies linearly with the temperature. So as we increase the temperature, the resistance also increases, and that will vary our sensor data, which is then sent to the xDot terminal, and we show the results in the putty. So as you can see here, we basically conduct this experiment in a room temperature environment. So the temperature is around 23.48 degrees Celsius, and it is pretty varying, but it'll not vary much because it's room temperature. But if we use it in our day-to-day life applications like fire alarm systems or something, it can detect varying temperatures, and we can send that data to our xDot system, which will then alert the user about the fire alarm. Now moving on to the next sensor is the ultrasonic sensor, which is used for distance detection. So this is our setup for the ultrasonic sensor. We've used Arduino Uno here to write our code to make it work, and then we send the data to our same UART ports in xDot, and we receive the data in the xDot. So what this basically does is like it detects the proximity distance, and as you can see in the results here, we have varied the distance, and we got the varying distance results also here, which goes all the way from 11 centimeter to 20 centimeter, and then again like 5 centimeter. So this is how we made use of the two sensors in our system. And also this ultrasonic sensor can be used in our daily life applications. For example, the sensors which are put behind our cars when we say we're parking, and then there's a beep sound as soon as we approach the wall. So that's how we can use our end-to-end IoT solution, and we can integrate both of them to make them work parallelly. And let's see an actual implementation of how our sensors are working in the next part of this video.
This is the second part of the video. Here you can see the sensor and the voltage divider connection connected to the xDot. The ultrasonic sensor is getting 5 voltage from the Arduino board. The Arduino board is connected to the supply directly coming from the laptop. This is the interface of Embed, in which we are loading the code and getting the binary file. After loading the binary file, we can see the sensor values. So by fluctuating the distance, we can see that the values are changing. That's it for this lab. Thank you.